Ghana has a target to reach self-sufficiency in rice production with the deadline set for this year, 2024. And that's according to the National Rice Development Strategy. But this seems not to be attainable because the country is currently doing between 30 to 40% of this particular self-sufficiency target. Well, this is mainly stemming from logistical challenges and good farming practices that hinders productivity. In today's episode of The Food Chain, we put a spotlight on the Crops Research Institute of the Council for Scientific and Industrial Research, who are introducing farmers to an integrated approach to fighting insect pests and diseases. My name is Emmanuel Bryce Kweku. Stay with us. Farmers are busy at work as they harvest matured rice paddy from their parcel of land. With their sickle, they cut every grown rice stalk to process them for the market. Rice is the second most important cereal in Ghana after maize. Local production is pegged at 40% of national consumption. The growing demand of the commodity has resulted in the importation of rice. The little that is produced in a country is also attacked by diseases and insect pests, affecting and reducing the yields. Alhassan Akologo Williams is a farmer at Kaira in the Offensive South district of the Ashanti region.
Obe tuwe dia so do wie ba kokora tuwe bi ni yini tuwe bi kura wo foma be san hema yebe aba ehemba no netene ko na ebi asata me so nya ho animanimu ya nsa mede nsa medo nti obe wani beba wo so no na san fa afuo no nyina nti ensuro kwanda me so aduro bie ni wona ma obo na esuro no de ebe hye but form no enduru form kan wura so de nka form na kan yini no but we de nka yini we are naming the we are naming her, but you nim quite fast so a bar. Aha, the names are no deep potting fee, the demano. There be a knock a car as I will more a can was I knew as a Bianson I was so. And I would do what I saw the Pamoa, a jazz assassin. Aha, I would win. A baby to you, and as baby to prepare and be also sat a good baby, say, was sinner. Na akaho na ekoro no wonso ntimi boa no se me sesa e de akosoro hu akokoja akwa na obeye de obehye no isa nwura na ye me hawa e ha me sa ayi no because omo ka ye so ye wadwuma wontimi enjai enu ana oye a orehwe oyere ne womba.
Kaira is one of the food baskets for the Ashanti region, producing staple crops to be transported to the city center and town. But rice farms in the community are seeing lower yields. John Satanga works as a crops officer in the district agric directorate.
The major problem the rice farmers are facing is the issue with stem borer. Because most of the farm lands, when they will start with everything very good, but in the middle of everything we have stem borer issue. So that's one of the major problems with stem borer. And some of the farmers too have problems with nursery management. Some of them, after they just nursing the field, they'll just leave it. So that's one other problem that some of them too have it. And another problem some of the farmers have is good agronomic practices. Yeah, these are the major problems that some of the farmers have.
How is that affecting the yield, the production capacity?
Yeah, then everything starts from the ground. If the nursery, from the seed, if the source of seed is not good, it will translate into a nursery, then to the yield. So these problems, like the seed, the nursery management, when the nursery is not well managed, the disease will start from nursery, then to go into the field. At the end of the day, to affect the yield.
Diseases that infest rice are mainly caused by bacteria, viruses, or fungi. Plant pathologist Dr. Atakwe C. Edu Senior and Dr. Kofi Frimpong Enin, an entomologist, explain.
We have major diseases of rice and also minor diseases of rice. For the major ones that are more occurring in the country. We have about 4 of them. The brown spot of rice, we have leaf blasts, then we have leaf scud, then we have RYMV, that is rice yellow mottle virus. Yeah, and then among the major ones, the most occurring is brown spot of rice. It occurs in so many communities and rice growing areas within the country. For these major diseases, mostly they occur within the rice growing areas, affecting the economic yield of rice. And normally it's due to the environment. When the relative humidity is very high and the temperature is also conducive for the organisms, the pathogens, then you see it more occurring. And then apart from the major rice diseases, we have other minor diseases that doesn't occur often, but it occurs when the conditions are favorable for the pathogens. And one of them is false mats of rice. Normally, it affects the panicle, the grains as well. It makes the grains chalky. That's affecting the yield and the quality of the rice grains. It's caused by a pathogen that we call Istulaginodia varians. It doesn't occur often when conditions are very favorable. That is when the microclimate of the vegetation is dense. Then you see this particular disease occurring a lot.
Through our work over here, we came across beetles. These beetles normally feed on the leaves, especially at the young stage, and because of that, the growth of the rice is retarded. And we also saw a lot of stem borers. Now, the stem borers will bore into the stem of the rice, and the whole tiller will die out. So it means that tiller is not going to give you any yield at all. We saw a lot of them over here. And then also we have this caseworm, where they also feed on the leaf. They cut the leaves, roll, and then you see them on floating on the water. And this also another critical pest that we found here. That also can reduce the yield as well as the vigor of the rice. And when the rice start producing the panicles, we have a lot of sucking bugs also coming in. These sucking bugs will suck the content of the rice seed or from the panicle that is formed. So if you look at the panicle, you see that the content has been taken out and you have only the chaff. And also at this stage too, we have some stem borers also coming in. And you see that instead of the rice panicle being filled, it becomes whitish and blank, or there's nothing in. So these are the challenges that the farmers reported, and we also seen over here.
The growth of the rice plant is also hindered by the mass of weeds that grow within the rice plantation. Dr. Stephen Atta is a weed scientist with the Crops Research Institute of the CSIR.
There are 3 different weeds that are affecting the farmers. And these weeds are all grasses. Weeds are put into 3 different categories, but these are all grasses which are in the same family as the rice. And so it's very difficult to manage. Weeds are also plants. And what they basically do is that they share the growth resources with the crop in terms of nutrients, sunlight for photosynthesis, as well as, water that the rice will, take and then and grow with it. But the weeds, because they are in the ecology already, they have the capacity to absorb these things better than the crop we have put there. And so if we are putting a crop there, there is the need that we protect the crop by removing the weeds for them to have access to all these resources to grow very well. One of the things that weeds also do in rice crops is that they actually become alternative hosts for diseases and pests. And so for diseases that affect rice, you have some grassy weeds in the rice field which are also attracting the diseases that would affect the rice. And they also attract insect pests that will suck fluid from the rice, as well as when it has started tasseling and then developing the rice itself, they also suck the sap from the pod. For wheat, they could lead to about 60% or more, sometimes even up to total crop loss, depending on the number, which we call the density of wheat in the rice field, to the extent that some people will abandon their field totally because they won't be able to manage the weeds in their fields. Over-dependence on herbicide is actually causing a situation where the weeds are developing tolerance and resistance. Just like in human, you have people taking paracetamol, maybe 4 at the same time, 4. And then now it gets to a time that they take 4 and it won't do anything for them. It's the same thing that we have in the wheat. And so farmers do over-application of these herbicides and repetition of the same herbicide. And that causes development of resistance in wheat. And so that is one of the things we are dealing with, so that farmers will know what herbicides to alternate to reduce such problems.
To mitigate the effects of the insect pests and disease challenges in the rice sector, the Korean Program on International Agriculture is supporting CSIR Crops Research Institute to develop a management strategy. This is expected to facilitate rice farmers to adopt good practices, including fertilizer use and water management that are cost-effective and less hazardous. William Lilani Kota is an agronomist with the CSIR CRI.
Took a part of the farmers' land to demonstrate good agricultural practices. So first, what we did was to bond the areas where we want to plant our rice. So you can see that these areas are bonded, and they are bonded in equal altitudes. So you see that when an area is low, we bond such areas, and the higher areas are also bonded as one plot. So we bond according to the altitude of the land. And we also rotovate with power tillers and then level. Rotovation and leveling is very important for rice production. The next we did was to prepare a nursery. And in good agricultural practices, it is very good to use very young seedlings. So 14-day-old seedlings are what we used. And they are transplanted 1 seedling per hill. If you transplant more than 1, it's just a waste. Some could transplant 2 and then turn out to 1. Research has shown that if you transplant 1 seedling per hill or transplant 2 seedlings per hill, you have no significant difference in the yield. So there's no point transplanting more than 1 seedling per hill. Farmers also have to be careful to carefully transplant so that they don't destroy the seedlings whilst doing that. It also helps to save some money, because seed is expensive, rice seed is expensive, so you could save some money. So after transplanting, we wait for about a week for transplanting shock to be over. You know, when you transplant, there's a shock, roots are broken, etc., and so the plant becomes a little yellowish when it is not well established. When it is well established, you see that the plant will resume its green color and begin to grow. So you then apply your basal fertilizer, the NPK. So you calculate the NPK to use, and then you apply it at that stage. When you apply your basal NPK, what you are signaling to the plant is to tiller. So tillering will take place. That is the hills you see there. You see that there are a lot of tillering. One is a plant and it has a lot of tillers. So these tillers these tillers develop into the panicles. Okay, there's also a time when we apply a top dressing fertilizer, usually urea or sulfate of ammonia, depending on your soil conditions. And that is also applied to enhance grain development and grain filling. So you see that our grains have developed and filled very well. So basically, that is what we did. You also have to make sure that the field is clean of any weed before you apply any form of fertilizer, because weeds are very good in consuming fertilizers even more than your main crop. So when you apply fertilizer with weeds on the field, you are sure to have no yield, because the fertilizer will be consumed by the weeds. So you have a clean field and you apply your fertilizer at the right time. So timely application of fertilizer is very good for rice production. When you are able to do that, you also have very good yield. We also brought some 4 varieties. They grow mostly agra, but we also brought 3 other types of improved rice to them. Different rice do well in different ecologies. So when we introduce these varieties to them, they select which ones are good for their ecologies and they cultivate them. There's no point growing the same variety everywhere in Ghana. So per your ecology, you choose which variety is very good and then you cultivate. And these help to increase their yield and to also reduce cost of production. You know, most of these varieties are climate resilient. For example, a CRI and Napa is very drought resistant. In these days where the rain is not coming, you see that they are still doing well on the field. And you see that our varieties are doing very well, even when there are no rains. So they are also climate resilient. And so we want farmers to pick and choose which ones are very good for them and to cultivate them on their fields. Also, we talked about timely harvesting. What will be the point of doing everything right and not harvesting on time? Most of the varieties have the tendency of shattering, that is dropping on the paddy field. And so you have to harvest at the right time. When you have about 80% of the grains gold color, like we have on our field here, it's time to harvest. And we've also told them not to harvest and put on the bare floor. They can put on tarpaulins, etc., so that they wouldn't incur a lot of post-harvest losses.
The integrated pest and diseases management approach combines various strategies for promoting rice production.
On the farmer side, once they see the pest infestation, which normally what their main concern has to do with the leaf destruction or those that feed on the leaves, like the beetles and that of the grasshopper is not a problem. So because of what they see, they will tend to apply insecticide, and sometimes they are applied frequently, especially in the case of the caseworm. No, the caseworm is such that the target pest always roll some leaves around it and then hide. So they will apply the pesticide or the insecticide frequently, but it will not get to the target. So we have to find an insecticide that will be effective. So what we develop for them is a threshold strategy. What do you mean by the threshold strategy? The farmers will scout for the symptoms of the pest, be it leaf destruction, the dead heart, which is caused by the stem borers, or the dead heart. So once they see it, they have to get a certain number of the plants of rice showing that symptoms before they apply any intervention. Until that limit is reached, they do not need to apply any insecticide. And we also recommended the right insecticide for them to use. That will be effective against those that feed on the leaves, the stem borers, and also the sucking bugs.
All the major diseases that I've actually touched on, they affect the plant yield and also the quality. Other interventions is what we have actually taught the farmers today. That is the IDM, Integrated Disease Management. So right from land preparation till you harvest, all the interventions that we have talked about, that is cultural and also chemical, and also selecting the best seed, all of them will control these major diseases. It will not actually curb the disease, but it will minimize the disease so that you get optimum yield.
Do you have an idea what they conventionally they were using to fight this?
Actually, for this one, they don't normally control because it's a minor disease. It doesn't occur often, so they don't have any intervention for it. But since it is a minor disease, it's likely to be an emerging disease as well. So it can, the incidence can go up if you don't actually work on the disease. So it's better, prevention is better than cure. So it's better we start researching on this disease. Immediately when we see the pandemic is going up, then we can actually come into it.
In tackling the weeds, the researchers adopted a less environmentally hazardous approach.
So one of the weeds we identified, in fact, for here, the farmers are telling me that this weed has been here for 4 years, and so they've not really named it. In other places, they call it a mohura because it looks like the rice. And one of the issues they have with this weed is that at the seedling stage, it looks like just the rice. And so it's very difficult to differentiate between this and the rice seedling. And so during hand picking of the wheat, they end up removing the rice seedlings together with the wheat. Or one other thing they do is that they then leave the wheat to grow and to the point that it starts reproducing before they see the differences, and then they remove. This is one of the scientifically, the scientific name is Echinoclea crusgalis. And this weed, the way to identify it is that at the seedling stage, at the leaf collar, the point at which the blade is attached to the stem, there are no hair. There is no hair there. But when you pick the rice seedling itself, there are a lot of hairs there. And so it tells you the difference between the rice and then the wheat. Also, one of the wheat we saw was Aponchia bodrese. Aponchia bodrese, that is how it's called in the local parlance. And the scientific name is Eleusin indica. And this weed is the one I said it hates waterlogged areas. And so when you have places where there is deficit in water, then these weeds will appear. But if you are able to allow some water to stand in the field, then you are able to eliminate these weeds. Also, one of the most difficult weeds that we saw here is one that they call copper wire, and scientifically it's Leptoclea species, and it's also very difficult to manage. So this together with the Echinoclea are those ones that we came in with the pre-emergence herbicide to deal with the seeds in the soil before they emerge. So doing all these things, we don't only depend on the herbicides, we also depend on other agronomic practices to control or manage weeds. In terms of fertilizer application, the spacing of the crop itself and other things. The fertilizer will help the crop to grow very well, develop canopy easily, so that it will also overshadow the weeds. The weeds are plants and they also need sunshine to photosynthesize. And so when you are able to go through these good agronomic practices such that your crop will be robust and build a canopy easily, it will be able to help you reduce your weed issues.
Also, you have to make sure water supply to the field is very good. There's a system we use here called alternate wetting and drying. When water is needed, we apply water through canals onto the bonds, into the bonds. And these are good for the growth of the rice plant and also good for suppressing weeds. There are weeds which do not like to be suppressed by water. And so when you apply water, these weeds die. when you keep the water for a long time, you begin to see that aquatic weeds will also begin to appear, water lily and etc. These also consume a lot of nutrients, and so you withdraw the water and these weeds also die. So alternate wetting and drying help in the growth of the plant and also help to manage weeds on the farm. So that also helps in water management. In many places, in irrigated areas, water to the field is sold, and so you have to manage in such a way that you don't incur so much high cost of production. So these are some of the things that we applied.
And so that is what the Crops Research Institute of the Council for Scientific and Industrial Research are doing to support farmers in the rice space as they combat these diseases that affect productivity. I hope you enjoyed today's discussion here on the food chain. Join me same time next week as we continue to find solutions to Ghana's agricultural problems. My name is Emmanuel Bratsquick.